Computer forensics is the process of collecting the information. After you've identified the information, you have to physically go and get it. My background is in computer forensics. I started as one of the Road Warrior collection guys, and our goal was to really go and capture the information. It was important to preserve the metadata. It was important to use tools that really preserve the information in a way that is forensically sound. And what we mean by that is we're able to capture the information without altering the information. Oftentimes in investigations, it's very key to try to prove time and date. And so if you simply capture the information in a way that doesn't preserve that information, you lose that pointer back to that information. And so the forensics process is about gathering the information in a way that makes sense, in a way that is useful, and a way that is sound. There's a lot of different things we can do. There's a lot of different data sets out there, as we just discussed, and it's key to go through and capture that information properly. The other piece of this is about capturing information that is unstructured. If you think about data on a computer, it's obviously very structured, it's very useful, it's very nice, but oftentimes you come across data sets that are unstructured. They're out there, they're big, they're complicated, they're confusing, such as server data or Oracle databases or other things. They themselves have structure, but the process of extracting that information is very complicated. And so you need specialized tools, you need specialized skills to be able to go through and capture that information. And so forensics is really about preserving that information and going through and being able to do a lot of analysis on large data volumes to try to figure out the best way both to capture as well as to extract content. And what are we able to do? So there's a lot of different things. The first one is full forensic imaging. What full forensic imaging mean is literally taking a bit-by-bit copy of an entire hard drive. Obviously, when a user logs onto the computer, they see their operating system, they see their computer, but there's also all the deleted space and unallocated space underneath. The full forensic image literally starts from zero all the way into the drive, and you're able to capture the entire computer from start to finish. What that allows you to do is look at both the live active data as well as be able to extract information from the deleted space or unallocated space. We also have the ability to capture network shares or do collections of logical home directories. One of the things that's key here is that you still have to maintain the metadata. There are tools that you can use that will allow you to copy data from one place to another without changing that information. If you simply drag and drop a file, for example, from your computer onto a thumb drive, you're changing the created date. And what you have is an opportunity where you could have a modified date that could be 3 years ago, but your created date is literally the moment it hits that media, because the created date is actually the created date for that media itself. And oftentimes in a case when lawyers are fighting, when people are getting angry, one of the first things they go through and they look at is the created date information, because it's the easiest point to go back and say that this information has been corrupt. And once you put a shred of doubt in there and you say, not only did you collect this in a way that is shoddy, what else did you do wrong? And so by ensuring that you're capturing the data properly, you're taking away the element of doubt. You're taking away the ability for the other side or the other parties to be able to poke a hole in your matter and your hole in your argument. And so it's imperative to really preserve the information in a way that really makes sense and is forensically sound. Same thing with webmail collections. When you download a set of documents from a Gmail, a Yahoo Mail, or what have you, it's still important to capture that information in a forensically sound manner. There are specialized tools that you can use. You also have the ability to pull this information directly into Outlook and then export out a PST, but you're still maintaining that data in a way that makes sense. You're still capturing that information in the proper way. One downside to logical forensic copies is that you can't get deleted items. You're able to preserve the information, but you're only able to preserve what's there. And so when you have to go to deleted information, you really have no choice but to do a full forensic image. And so that's just one thing to consider as these cases go on, is that if you're going to need deleted items, you have no choice but to go down that path. The problem with forensic imaging is it takes a long time. It pulls in a lot of extra information because you're getting not only the live information, you're getting the operating system as well as the unallocated space, which is great because there's a lot of information there, but it also does expand the amount of information someone has to look at, which is more complicated. In terms of phones, nowadays everybody's got a phone, as we mentioned, and we're able to preserve that information in the same way that you would a computer. We're able to extract that information from the device itself. You can pull the text messages, the videos. You can capture GPS information from a phone. When you put a map, an address into your Google Map, and then you run a search, that information actually stays on your phone. And so if you're trying to figure out where a user was, at a specific date and time, going to their phone and looking at their maps, looking at their GPS history, it can be very helpful, because there could be really good information in there that you can really pull from the phone itself. And again, people also take a lot of photos. You are able to track their locations from their photos themselves, from the metadata of that information, and what have you. There are some downsides to capturing phones. The iPhones today are pretty complicated because some of the information is stored in the encrypted container. There are utilities out there that will crack some of that, but once you add in phones, you do add an extra layer of complication to any specific case. Same thing with social networking sites, Twitter, Facebook, LinkedIn, all that information is out there and available to be captured in ways that are useful. There are tools out there that allow you to preserve that information in the same way you would anything else. And so, nowadays, that information, which used to be very difficult to capture, it's now just another data point that exists. The power of forensic software, this is a screenshot here from a forensic software called EnCase. EnCase is kind of one of the industry standard tools that exist out there. And what this allows you to do is really see under the covers. If you look at a computer and you're looking at it just in Windows or Windows Explorer, you see a lot of information, but a tool like this allows you to see information about the information itself. You're able to see not only the location, but you're able to see the pointers to where the data exists itself. You're able to see whether it's been deleted, whether a file has been deleted and overwritten, whether a file has been renamed, or the file extension itself does not match the actual file. That information is pulled from the file signature as well as the header. And so tools like this allow you to do your analysis on the information that you capture. And so these are really critical to a process to ensure that you're getting all the information that you possibly could. A moment here to talk about information. Most people think when they delete a file from their computer, it is actually gone. That is false. Most files are there until they are overwritten by another file. For example, if you have a file and you simply delete it, all you are actually doing is deleting the pointer to that file. And so the file itself exists. That file is still there until you actually go back through and capture that information. They're never actually deleted, they're just simply overwritten. And as you have a file that you're looking at, you may have a file that is partially overwriting another file. For example, in this screenshot, you can see there are files that are a handful of blocks long. For example, if you have a file that's 5 blocks long, and then you delete that file, in the next file that comes in is now only 3 blocks long. Those 2 remaining blocks that are for that original file still are there, and you're able to recover information from those 2 blocks of the file, and you may be able to get information from there that would still be useful. Sometimes in a case, simply the presence of another file is enough to simply turn the case in your favor. People always think of files being deleted, and then they forget. The most, the easiest and best example of an actual hard drive that exists, even after being destroyed, is the black box from an airplane. Obviously, this exists, and every time an airplane crash occurs or whatever, people are going to look for the black box. The black box is just the most complicated hard drive out there. It's simply another data source, but you're able to literally destroy this and crash it to the ground, and then people are still able to find this and recover information. And so if you think about it, a normal user isn't going to destroy their hard drive, and if people are able to get information back from a black box, they're obviously able to get data from a typical hard drive. And so it's definitely a thing people need to consider when they're looking at information. Is there deleted items going to be available, and if they are, where could they possibly be? The answer is still on the computer and still in their unallocated space. And so if you're looking for deleted information information, if proving that a user did a malicious act is important to the matter, it's very key to go and do a full forensic image and then go through and do an analysis of the unallocated space and really recreate the history which can be done from looking at the deleted items. Lastly, it's important to maintain a record. It's important to show who had access to the data throughout the process. One of the things that's very key in this process is maintaining the chain of custody. The chain of custody are forms that document the process. It documents the ownership, not only of the original custodian, but as that data and that source information was transferred from one person to another, the chain of custody really lays out that path. And so if you were to take a phone or a computer from a original person and now you give it to the forensics person, the chain of custody documents that process. It says that this has been transferred custody over to the new user, and then anything that happened after that point in time is obviously not on the original custodian, it's on that user. And so it's important to maintain that chain of custody to really document the process, and not just documenting the original collection, but all the way through the phases of the EDRM to ensure that you know where the data is the entire time. It's very key to maintain this throughout the entire collection, through processing and through delivery back to the custodian at the end of the case. That way you can ensure that the data has been properly copied, that it's been transported properly, and that it's also been stored properly. It's important to store the information in a forensically sound manner. It's important that when you're actually doing your analysis, you're doing your analysis on a copy of the drive and not the original, so you don't corrupt any information from the original source. And so the chain of custody really documents that process and documents the steps to be taken, and really kind of ensures that that process, again, is forensically sound, and that the media itself is secure all the way through the process.